Hey there, class. Mr. Prusky here. Hope you're having a good day so far. We're continuing with 2.4, which is use postulates and diagrams. Our essential question is, how do we use postulates with points, lines, planes, and sketches? So this is kind of talking about, this whole chapter is about reasoning and logic and proofs. And in order to be able to do some proofs, we kind of need to know like some postulates about certain shapes. And so this will be kind of a way to do that. So we have a warm-up here. It says, write the converse of this statement. If someone likes Harry Potter, they are a neat person. See if you can write the converse of the statement. Go ahead and pause the video. All right, so converse, remember with converse we think reverse. Okay, so we're going to flip it. So this is the, someone likes Harry Potter was the if. They are a neat person was the then. So we're going to flip it around. Instead, we're going to write if someone is a neat person, then they like Harry Potter. Okay, so that's the converse. So remember, sometimes the original statement's true or false, sometimes the converse is true or false, and if it's true both directions, that means that it's a biconditional statement, okay? Obviously, someone likes Harry Potter, then they are a neat person. That's a given. But there's not neat people who do not like Harry Potter. So everyone who's neat needs to like Harry Potter. So that's just kind of a joke. But yeah. So, okay, let's get moving here. So definitions. A line perpendicular to a plane. A line is perpendicular to a plane if and only if the line intersects at what? Intersects the plane and a point and is perpendicular is what? Perpendicular to every line in the plane that intersects it at that point. Okay? Basically, if you have a plane, it's basically going to intersect the plane at a right angle. Okay? We'll put a right angle here. So that's basically all I need to know. So that's good. Okay, so we have some different postulates here. We're going to group them. Okay? So we're going to group, I'm going to put a circle by 5 and 6. I'm going to put a triangle by 7 and 11. And then I'm going to put a square by 8, 9, and 10. Okay, these are ones that kind of go together here, okay? Actually, let me use different colors. You won't be able to see this, but I'm going to add different colors here. So we got those. We got these two. And then we have these three. Okay? All right, so postulate 5. Through any 2 points. So it needs to be exactly 2 points or exists exactly 1 line. How many lines? 1 line. Okay? Postulate 6, a line contains at least 2 points. How many points? 2 points. Okay? So it kind of goes both. It's kind of the statement and its converse. Okay? So a line needs at least 2 points. Okay? All right. Let's do the red ones now. If 2 lines intersect and their intersection is exactly 1 point. How many points? 1 point. Okay? And down for postulate 11, if 2 planes intersect, then their intersection is a line. It's a what? It's a line. Okay, we kind of talked about this previously, but like if 2 lines intersect, they make a single point, and if 2 planes intersect, they make a line. All right, then we're going to do the blue here. Postulate 8. Through any 3 blank points, there exists exactly 1 plane. What kind of points were there? Do you remember? There was collinear and non-collinear. Do you remember which one it was? It was non-collinear. They cannot be in a straight line to make a plane. Okay? Non-collinear. And same thing for postulate 9. A plane contains at least 3 non-collinear points. All right? And the last one, postulate 10. If 2 points lie in a plane, then the line containing them also lies in the plane. All right? Sounds good. Okay, so on the next page, it's identify postulates from a diagram. So it says write examples of postulates 9 and 11. So postulate 9, if you recall, says a plane contains at least 3 non-collinear points. So for postulate 9, we need a plane that has 3 points that are not in a straight line. So if we look at the planes here, we have plane Q right here and plane P right here. Which one has 3 points that are not in a straight line? Hopefully you can see that plane Q contains which 3 points that are not in a straight line? Well, we have V, Y, and W. All right, that would be an example of postulate 9. Postulate 11 says, if two planes intersect, then their intersection is a line. So where do these two planes intersect? You can see they intersect right here in the middle, which is what line? We have line B. So intersection of planes Q and P is line B. All right. Okay, so we have a checkpoint here. Why don't you guys see if you can fill out the checkpoints? Give it a try. All right, it says, which postulate allows you to say that the intersection of line A and line B is a point? Well, that would be postulate 7 said that. Postulate 7. All right, we need examples of postulates 5 and 6. Postulate 5 says, through any 2 points, there's exactly one line. So we need an example of 2 points that lie on a line here. Well, we can see that we have X and Y. So this would be line A passes through X and Y. Okay, that'd be an example of that postulate. And the other thing too, postulate 6 is kind of a similar thing. A line contains at least 2 points. It's going to be the same thing. Line A contains, actually we'll say this, yeah. So line A contains X and Y. All right? Okay, let's keep moving here. So content summary, interpreting a diagram. These are kind of important here to be able to tell. You need certain notation or things that are in the diagram in order to be able to prove some things, okay? So what can we assume from this diagram here? We have this diagram over to the right over here. So what can we assume? Can we assume that all points are on the same line? Well, no, not really. Are they all on the same plane? They are. They're all on that flat plane P. So what's it called when they're all on the same plane? They are coplanar. Okay? There's no points that are floating above or below here. All right, and then it says AHB. AHB is this angle called 1. And which one are a linear pair? Which one is a linear pair with AHB? Well, we could do this one over here or this one over here. Sorry, you're not going to be able to see that. So you can see AHF or BHD. Yeah, what did I do here? That's not correct. AHB. Yeah, I don't know. I wrote the wrong thing here. We're going to say this angle right here. Angle AHF is a linear pair. It makes a straight line. What are some vertical angles with the AHF? AHF is right here. Which one's the vertical angle? Is it this one, 3, or 4? It's going to be 4. So it's going to be angle DHB. DHB. This angle right here is vertical with this angle. Okay? AH, J, and D. Are they collinear? Are they on the same line? They are. They are literally on the line, so they are collinear. And we know that AD and BF intersect at which point? AD and BF. It's going to be point H. Okay, so we can assume those things because either they're on the line, they're on the plane, but some of the things down here we cannot assume. Okay, we can't assume that these points are that's G, F, and E. These points right here are collinear. There's not a line on them. Okay, there's certain things we cannot assume. We can't assume that they're 90 degrees because there's no right angle symbol. Stuff like that, okay? So let's keep moving here. All right. Sketch a diagram showing what's this symbol right here? That is segment RS perpendicular to what's this symbol right here? Line TV intersecting at point X. Okay. So we're going to draw RS, a segment RS. Let's do that first. Okay. Here's segment RS. Perpendicular to TV. Does it say it meets in the middle or no? It doesn't say it meets in the middle. So let's just draw, it says perpendicular to TV. So this is RS right here. Oops. This is RS. Okay. And then it says that TV is perpendicular. So we're at a right angle. TV V, and it's going to extend beyond, make a line at a right angle like this. Okay? And that would work. And it intersects at point X. This is point X right here. Okay, so that would be an example of a drawing here. It satisfies all the criteria. It's perpendicular to TV. RS is perpendicular to TV at a right angle, and it intersects at point X. It does not say it meets at the midpoint, which would be a perpendicular bisector, but we haven't talked about that quite yet. Okay, last thing, we're interpreting a diagram in 3 dimensions. Why don't you guys pause the video and see if you can figure out if these statements are, we can assume it or we cannot. Okay, go ahead and pause the video. All right, E, D, and C are collinear. Can we assume that those 3 points are on the same line? We can, because they literally are on that line right there. Good. The intersection of line BD and line EC is D. BD and EC is D. Is that where they cross, those 2 lines? We can assume that. That works. All right, how about BD is perpendicular to EC? Can we assume that? That is a no, we cannot, because there's no perpendicular or this perpendicular symbol. Okay? How about the last one? How about EC is perpendicular to plane G? We cannot assume that. Same thing. I'm going to put these quotes means the same thing as this. Okay? And the last thing, we can say that BD is the intersection of plane F and plane G. Well, is this where those 2 planes meet? Right there? It is. That is true. We can assume that. Okay, well, that is all I have for you today. Thank you for watching. Have a great day, and we will talk soon.